There's a type of electrical device out there that is code compliant, yet 80% of my viewers are not aware of it and haven't used it in the past. These are called self-contained devices. This is an example of an outlet that is self-contained, so it has the electrical box or junction box built in. Now, these are predominantly used on mobile homes or manufactured homes or in RVs. And unlike the three major ways that we know how to wire a device, starting with the most common, which is side wiring, that's a J-hook in the clockwise direction around the side of a screw terminal, or speed wiring, also known as backstabbing, where 14 gauge wire is pressed directly in the back of a residential grade outlet. This is not my favorite, but commonly found in new construction just to save time and overall labor costs. Or the third method, which is my preferred and found on commercial grade outlets, which is back wiring. You have a plate that is pulled against the wire as you screw in the terminal. That makes for a consistently secure connection. These self-contained devices actually don't use any of those. They use a completely different way to wire the device, and it's a little scary actually. Let's go take a closer look, and we'll talk about a rental property where I actually had a failure on one of these devices and what I did to fix that. So this is the exact one that I had in that rental property. It's an example of coming power in, power out from one device. It's made by Pass and Seymour. It's a 15 amp outlet certified by Underwriters Lab, so it has the UL stamp. And to get in the back of this, there's actually 4 tabs, 2 on each side, and it takes a little bit to open things up. So this is the back cover that you'll remove, and then on the inside, it is immediately apparent how different than the normal 3 ways that we just reviewed of wiring an outlet. This is a little bit more common in low current, like an Ethernet line, where you have 2 different contacts or 2 different blades here, and then you press the wire in. Those cut the insulation and then make contact with the copper. Now, it's probably pretty apparent why that could be an issue. There are specialty tools that will press these wires completely down, securing them in place and providing the best contact possible. But the problem is very few people have those specialty tools. So you're pressing on these with screwdrivers or something a little more blunt so you don't damage, but you can see here's a little damage in the insulation right there on the neutral side. And then if we remove the wires, then we can see the actual contact area from the ground to the hot side there. You can see where it made contact. You can see where it barely, if at all, removed the insulation from the top one. Again, barely removed the insulation from the outside. That was damaged. That was not in contact. Here's a little bit. The contact area is minimal, and that is why these can be so dangerous. Because the smaller the contact area, the more heat generation, and that is the exact type of failure I saw in the past. Do me a favor and actually jump down in the comments. Let me know if you have any experience with these and what your overall take is. Either way, I'm interested to hear your feedback. For me, these are a no-go. I just really do not like the overall design. I'm a bit surprised they meet code and also are UL certified. If you want to dive deeper into that failure, check out this video right here and I'll walk you through the exact failure mode and what I did to correct the overall situation. Additionally, below the video, there is a link to submit your questions. We are doing weekly Q&As on our new Everyday Home Repairs Help YouTube channel, and I'd love to help you guys out. So thanks for joining me on this video, and we'll catch you on the next one. Take care.